applications with Amazon S3. We are going to see how to transform your data with S3 Object Lambda. My name is Fatima Kamal. I'm a storage specialist, solutions architect here at AWS. So in today's agenda, we'll be seeing an overview of serverless applications, and we will see how to configure serverless applications using Amazon S3 event notifications. We'll also see how to further simplify serverless applications using Amazon Event Bridge. We'll go over Object Lambda and how to transform your data using S3 Object Lambda. We'll end the session with a small demo to see how to configure S3 Object Lambda and transform your data. So let's get started on Amazon S3 serverless architectures and what it entails. So in traditional softwares, we brought the data layer to the compute layer. And this was inherently problematic because we have seen that the data layer grew exponentially. And as the data layer grew, the developers had to make sure that the compute layer is scaled in multiple fleets, and when you hit, especially when you hit peak workload times. But what happens when the peak subsided? You end up with all these over-provisioned capacity or compute layer. So these all created an operational overhead for our developers. What the S3 to Lambda serverless pattern does is that it brings the compute layer to the data layer. And this could be your objects, your files, your databases. And this is also super helpful for our developers because you don't have to worry about the compute scale. Lambda would scale up automatically and down based on your workload patterns. And at your peak load, Lambda will scale up, and once the peak subsides, it would scale down. So developers didn't need to worry about scaling constraints, especially when writing their application. So how do we do that with S3 event notifications? When you are building modern applications using S3, you can use S3 event notifications to notify you when certain events happen in your S3 bucket. And S3 event notifications, they are designed to be delivered at least once and within seconds. So you really have low latency there. And they're absolutely free. Right? And S3 can publish notifications for a variety of events such as object creation or deletion, restoration from S3 Glacier, throughout an object's replication journey in S3, and also the lifecycle transition within S3, with different access tiers of S3. Lastly, S3 events can be published to an SNS topic or an SQS queue. It can even trigger a Lambda function or send an event to Amazon Event Bridge. So now that we have seen what is S3 event notifications, let's see how to configure it. And to do that, go to the bucket, go select the properties, and when you scroll down, you'll see event notifications there. Click on Create Event Notifications, and you'll get these pages, right? This is where you define the rules for it, where you give it an event name. You can type in a prefix or a suffix and then select the event types. The event types could be, again, object create, object removal, object restores, the object ACL events, the tagging events, the replication event, lifecycle transitions, and intelligent tiering events. So select the event based on the requirements that you have. So now that you have selected the events, you want to have a destination for it to be published, right? So you can, under destination, you can select an SNS topic or an SQS queue to publish it to. Or you can use it to invoke a Lambda function. When you save changes, there you go. Your event notification is configured for that particular bucket. So now that we have seen how to configure S3 event notifications, let's go over some serverless applications and their architectures, right? So in this diagram, what you're seeing is a serverless architecture, and this is typically what we want to see, how a serverless architecture should be. You have a diverse set of objects in the S3 bucket, and they're loosely coupled, right? So when there is an object change happening in your bucket, it's going to invoke downstream applications. But oftentimes than not, it ends up looking like this. So they often look like this because we want a single object to trigger to multiple applications downstream. Also, we could have multiple objects that need to react to a single application. And so it can get pretty challenging with these workflows because with S3 event notification, it can be mapped from one to one. So a single source can send to a single destination, and you also can't send from overlapping prefixes. So it's very common to have like hundreds of prefixes, and these workflows can get a bit challenging. So what if customers want to build around such a workflow, right? So customers have to build single-use mechanisms to manage these kind of workflows. What would that look like? Let's see that. So in this architecture, we had a customer that needed a single object to drive changes to a translate function, to then add a record to the DynamoDB table, start an EC2 instance, and start the step functions of workflow, all with a single object. And customer was specific. They did not want to create multiple copies of the same object. So in this architecture, what they did is that they built an SNS bridge, right, where the object invokes SNS with S3 event notifications, which is then subscribed by 3 different Lambda functions and also an SQS queue. So you can see lots of things are going around here. In this architecture, you have to manage 3 different Lambda functions just to drive a single application, which can get challenging along with an SQS queue. So what did we do? We saw this, and we simplified it for you using Amazon Event Bridge. So here, with Amazon Event Bridge, all these events can now be directed to an Amazon Event Bridge, right? So each object event within an S3 bucket can trigger up to 5 different applications. So what is Event Bridge? Amazon Event Bridge was launched as a part of rebranding of CloudWatch events in 2019. So let us look at some of the benefits of Amazon Event Bridge. Right? So with Amazon Event Bridge, what you can do is a single event can easily trigger multiple workflows. So using industry pattern matching, you can filter your events by prefix or any other parameter in your payload, such as IP address filtering or create date of the object. And with at least once delivery guarantee, you can now count on events being triggered for every object. So now that we have seen what is Amazon Event Bridge, what it does, what are the benefits of it, let's go and see how to configure it. And to do that, go to your desired bucket, go to the properties page, just below event notifications, you would see Amazon Event Bridge. So click on the edit, and you will either have an on or off, so select on. Now you will have events triggered for all the events that's coming into the bucket. So once you do that, what you have to do is now you have to go back into Amazon Event Bridge to configure some rules, because you don't want all events to be triggered. So you click on Create Rule, select an event pattern. There's an event matching pattern, such as a predefined pattern by service or a custom pattern. So if you want something specific like a prefix, you use a custom pattern, or you can narrow down to see which pattern you want to do. You can select object creation if you do a predefined pattern, and you can also select the bucket that you want to do it for. So once you do it on the left, you will see that a JSON statement on the right automatically filling up. And click on Save Changes, and your Amazon Event Bridge is now configured for your S3 object bucket. Okay, so now we saw how we could simplify all this with Amazon Event Bridge and S3 event notifications. So let's move on to Amazon S3 Object Lambda. It is what you use to add your own code to standard S3 GET requests to process and modify data returned to your application. It's fully managed by AWS Lambda function, and it eliminates the need to create and store derivative copies of your data or make any changes to your application code. So you might be wondering, what are these common use cases that I can use S3 Object Lambda for, right? So let's look at some use cases here. So firstly, compression or decompressed data, right? So if you want to, some customers might want to store the data compressed and uncompress it while their application retrieves the data. Or PII redaction, where a data set might have personally identifiable information, and you want the application to redact that particular information because they don't need to view it. Or image reformatting, where you want one copy of that image to be reformatted on the fly when it's viewed by a mobile versus a laptop. Another common use case I'm seeing in the field is people using it for S3 malware scanning. You can integrate it with third-party applications to, as they do the read on the fly, the data is checked for malicious content and it is quarantined or deleted based on the rules you set up. Some others are data augmentation, filter rows and records, custom authorization, etc. And also Ryanair, which you mentioned in the beginning, they used Object Lambda to change their COVID vaccination status and negative PCR test to upload their data in a certain format. And that was easily done by S3 Object Lambda. And it was done on the fly, and they did less than 3 days to do it and reduced a lot of developmental effort for Ryanair. So do check out this blog. Okay, so now that we've seen what is S3 Object Lambda, let's see why would we want to use this, or what is important about it, right? So one of the use case that we are going to be seeing today is that customers usually have a large shared data set, and it's used by multiple applications, where each application requires a slightly different view of the data to meet its specific requirements. For example, let's say I have a data set here. It's created for an e-commerce application, and it contains personally identifiable information. And that is not needed when this data is consumed by an analytics application. Whereas when it is consumed by a marketing application, it needs to be augmented with additional information. So what we see here is that depending on who is really accessing the object, a different variant of that object is needed. So prior to the release of Object Lambda, customers had to take one of the two approaches. The first approach is to create and manage infrastructure as a proxy layer in front of S3. This proxy layer will then go ahead and create derivatives of objects in flight. And the other option is to simply create derivative copies of the data and store all of them so that each application has its own custom-built data set that's tailored around it. Neither option was ideal because they got expensive and difficult to manage. And this is really the value proposition of S3 Object Lambda. It's a completely managed solution. There is no infrastructure to manage. You could simply author a Lambda function, and with your own custom code and Object Lambda, functions are automatically invoked when you request objects from S3, processing the objects before returning them to you. So we saw why it is important. So let's see what happens in the back end when we do this, right? So this is a data flow diagram that's going to answer those questions for you. So what you're seeing on the left is an application, and that application is now making all of its S3 requests to the Object Lambda access point. And these are the stuff that we'll be covering in the demo as well. The S3 Object Lambda access point will now evaluate the request, and if it sees it's a GET request, it will automatically invoke the Lambda function and send it to the S3 access point, which will then get the object from the S3 bucket. The Lambda function will apply its own code to that particular object to reformat it or redact it based on what we have in the Lambda function, and the GET object is the GET request is returned. What if it's not a GET request and it's a PUT request, right? So then what happens is that as soon as a request comes into the S3 Object Lambda access point, it gets relayed directly to the access point because it's a PUT request, any non-GET request. And then the normal operations are carried out in the S3 bucket. So you can see here why the S3 access point plays a key supporting role, because any request that's coming in, whether it's a GET or a non-GET request, it gets forwarded to the access point. So that is what happens behind the scenes with S3 Object Lambda. So to help you understand this further and how to configure this, we are now going to play the demo, go to the demo and see how to configure all this with a front-end application. So let's go to the demo. Here you go. This is the front-end application that's pre-deployed in the interest of time. So in this architecture, I have a front-end web UI authenticated with Amazon Cognito and Amazon Amplify framework. And there is an API gateway which takes care of the create, read, update, delete operations. A Lambda that's basically a policy API router and validator, and a DynamoDB table to put an entry of all the custom IAM policies that we're going to put in here. This is the control plane. On the data plane, we have the S3 bucket, which stores the data, supporting S3 access point, which actually supports the S3 Object Lambda access point. The S3 Object Lambda access point would evaluate the request, send it to Lambda. Lambda will again apply based on the custom IAM policy, would return the request, the GET request, by redacting the data or image formatting, whatever we have done in the Lambda function code, right? So this is, in short, the architecture that we have used to deploy the front-end application to do the GET request. So to get started, this is my Amazon AWS Management Console, and we are going to see how to deploy that S3 Object Lambda access point, how to create that S3 access point, how to integrate that pre-deployed Lambda function into the S3 Object Lambda access point. So to get started, I'm going to type in S3 to go into my S3 console. Select S3 and So that's my S3 console, and these are my buckets. I'm going to select the last bucket. That's where I have my data set. So here you go. That's my data set. So I'm first going to create an access point. So click on access point, click on create access point. So here, let's give it an access point name, and the bucket name region is all pre-filled. So let's go on to the network. I'm going to select internet because VPC is only for specified requests within the VPC. Under block public access setting for this access point, I'm going to leave it as is. I'm going to keep it checked. Under access point policy, I'm going to leave it as default. You can ignore the error that happens on the right and say create access point. So now my access point is created. There you go, it's here. So now I'm going to go on and create the S3 object lambda access point. So for that, I'm going to go back into the S3 console and select object lambda access point. Here, create object lambda access point. Once I say create, I will have to scroll to the top and give it an object lambda access point here. Okay, so now I have to select the supporting access point. So click on browse, and that's an access point we just created. So select that and say choose supporting access point. So you can see the bucket is pre-filled now. So we'll move on to the Lambda function for this, okay? Here we have already pre-deployed the front-end application. We have packaged the Lambda function. Everything is ready to go. So the Lambda function is now here populated. I'll go ahead and select this particular Lambda function that appears here. So select on the Lambda function, and I can click on that view button to get a view of the Lambda function. So that's my Lambda function console, and there you go. It's too large to be viewed for inline editing, but you can see that it has a runtime done in Python 3.8. So back to my S3 console, I'm going to leave everything else as is and default. Block public access would still be on. Say create object lambda access point. Now my object lambda access point is created. So click on it, and you would see that there you go, my data set is there. And if I go onto properties, I have the Amazon resource name, and I would need this to do my GET requests or my list objects. So I'm going to open up my Cloud9 IDE to run some of these commands. So here I'm going to now do a list object, right, on that particular ARN. And when I do that, my data set is returned. It's 35 MB. Perfect. Now let's do a GET object on the same bucket ARN and for that particular data set. So what should happen is, let's see. I'm getting an denied, an implicit denied here. So what that essentially means is that without any custom IAM policy, I have an implicit deny on any of the GET requests that's coming in. And this is similar to the policy evaluation in any Amazon IAM, right? So for this, I need to put in a custom IAM policy on my front-end application to ensure that that policy is evaluated and it is right. To do that, I need to go into my front-end application to put in a custom IAM policy. So let me go to the front end, and I do a create policy here. I put in a policy name, and I put in the policy document. My resource is my ARN, and under anonymized data, I have selected column as V3. Under action, I have a get object here, and principal is all, but you can change that to any user or role that you want. Submit this. Let's go back to the IDE and run the same command again. So I'm doing a get object. This time it succeeded, right? It's successful. I'm going to check that data set, and as you can see, V3 is now anonymized, and this is exactly what I wanted for my application. I can play around with this to make different changes to my application. So if I go back to my API policy and I edit it, so let's say I want to change from anonymized data to remove column and submit the changes, and I go back, run the same command. Let's see what happens. So let's go to the data set to see what happened to V3, right? So there you go, V3 is gone. The data is completely gone, and it is transformed on the fly for you as you retrieve this data set through your application. So I can, again, go back to the policy. I can make whatever changes I need. Instead of remove column, I can do remove data. In that case, V3 column would exist, but the data there will be a blank space with commas between the previous and the next value. So this is how you can transform data on the fly, and you can play around with it. And that brings us to the end of our demo, where we saw how to transform your data on the fly. Yes. So let's switch back to our slides. So yeah, thank you. Thank you for joining my session. Do scan the QR code to get access to all of the Pi Day presentation decks. And let's take some Q&A right now.
All right, yeah, excellent presentation, excellent demo. I thought
Thank
it was
you.
really interesting.
Love the demo.
Yeah,
I learned my demos.
Yeah, yeah. I do have a question though.
Sure.
How is application latency affected when these modifications are happening in the GET request?
Logic is not flexible enough to accommodate that latency, or if it's very sensitive to that latency, it could get a bit challenging. And there is a latency timeout of 30 seconds with S3 Object Lambda. But what you can do is when you are building these functions, your Lambda functions, make sure you create them as idempotent Lambda functions. And what that would do is to ensure that you identify and prevent any duplicate requests or any inconsistent request within your application. And that can reduce the latency in these GET requests when you take care of all that logic at the AWS Lambda function level. So that's a good way for you to reduce latency, or take care of throttles and all that.
What about support for inline lambdas with put requests? And after that, to save you time, what's your favorite Pi?
Okay, so we are working on the inline put request. In the fullness of time, we are looking to expand into extending into other areas too. But do leverage the S3 event notifications. Have it trigger to a Lambda function, and you can build it with your put request using a Lambda function. So you can leverage it with existing architectures that we saw using S3 event notification or even Amazon Event Bridge. And to answer the last question, I already mentioned Blueberry Pi. So I'm going to do sweet potato pie that's going to be served. That's usually served at Thanksgiving. That's my favorite one too.
Object Lambda is just fascinating to me.
Yes, very fascinating. I think it's a very cool product. I'm excited to just start playing with it right after I leave here.
Yep. And just, I'm seeing what customers build with it. It was one of those features that I think S3 launched that didn't have 3 or 4 defined use cases for it, where customers, it's super obvious for them to use it. There are a few of them, but I think it's just kind of one of those where let customers' imagination take hold.
Yeah.
And kind of figure out what they want to do with it. And I think that's what we're seeing, some of the customers' use cases of that, of how they're using S3 Object Lambda, how they're modifying objects on the fly. That's kind of just one of those go use this cool new feature, this new technology in line with Lambdas, and then just build new things.
Yeah. And anytime you say serverless, you can just use tools like this without having to set up an infrastructure. You can just write some code.